So this is the second side of the sheet, playing with equations, expressions, writing expressions and doing some mathematical gymnastics with them. So we're told this rectangle has perimeter P. Find an expression for A in terms of P, so that means we want A equals. So we'll start with what we do know. Perimeter would be A plus A plus 2 plus A plus A plus 2, because of course there's two other sides there. Right, but we want A equals, so now we just need to rearrange the subject of the formula. We'd start by subtracting 4. So that means 4A equals P minus 4. And then to get A equals, we'll divide the whole thing by 4. Really important we don't cancel the 4's at this stage, because there's a minus in there, so we're simplifying. We can't just cross out the 4's. Right, number 13, an expression for B in terms of A. So this time we want B equals. It's a right angle triangle. So using Pythagoras' theorem, A squared plus B squared equals 10 squared, which is 100. Now we want B equals, so we want to rearrange this formula. We'll start by getting rid of the A squared and we'll change that to 100 at the same time. So therefore to find B would be the square root of 100 minus A squared. We only want the positive square root because B is a length. While we can square root the 100, while it's got the minus in between, we can't. Interesting to note that underneath the square root there we've got a difference of 2 squares. We could write it as 10 minus A, 10 plus A, but not really gaining anything. Good to spot though. Right, hence find an expression for the area of the triangle in terms of A only, so that means with no B. So we want to get rid of the B term. So area of a triangle is base times height divided by 2. So we go A times B and we want to divide that by 2. Now we do want the A, so we'll keep the A in the divided by 2. But instead of writing a B, because we don't want B, we'll put that term there. So now I have an expression for the area in terms of A only. So all I need to know for the triangle is the value of A. I can substitute it into those two places and work out the area. Right, so we're running out of room here clearly. The sheet's quite tight. Into the bottom of the page. The square has got perimeter P, so clearly P equals 4A. A plus A plus A plus A. Find an expression for the area of the square, which would be A squared, but we want it in terms of P. In other words, I don't want any A in that formula for the area. So coming back to our first formula and rearranging it, I can see that little a is a quarter of the perimeter. P divided by 4 would give me little a. So therefore the area is little a squared. So if we write it as P over 4 squared. So now I have a formula for the area in terms of P only. So once I know the perimeter of the square, I could substitute it in and work out the area. Hence find an expression for P in terms of A only, so that's just rearranging it. So we have P equals, so if we start by timesing by 16, and clearly P is the square root of 16A. Once again it would be positive because it's perimeter. Now because this is multiplied, you can actually square root each term individually. The square root of 16 is 4. And we don't know the square root of A, so we'd still have to multiply by the square root of A. So that would give me the perimeter. I'd need to square root the area, of course, which would give me little a, and then if we times that by 4, we've lost the questions. So we'll just go back. There we go. we might have to stop the video there, pause it. Right, so I found some questions. Number 15, moving quickly now. You can pause and read and try it yourself. Total perimeter of the semicircle. So the total perimeter of a circle is 2 pi r, but we've only got half a circle, plus that length there, which would be 1r plus 1r is 2r. So that would equal the perimeter. And we can simplify that, which would mean we could write it as p equals, pull out a common factor of r, pi plus 2. Okay, in part B, an expression for the area of the semicircle in terms of p only, so we want A equals for the area. Area of a circle is pi r squared. We've got half the circle. Rearranging over here, we can write r as p divided by pi plus 2. Let's see if that helps. And then we want the radius squared. So quite a tricky one. Substituting for r in there. Not a lot of tidying up we could do. We could square the p on the top line. Got a 2 on the bottom, and we still need to square the pi plus 2 on the bottom. It's very difficult for that last one.